In this lesson, we will look at number patterns, and we will start with number patterns that have a constant difference. Consider the following number pattern: 5, 7, 9, 11, and so on. This is a number pattern and it is made up of terms. You will notice that the terms are separated by a semicolon. And we want, in this particular question, to write down what we call T1, and then write down T2 and T3. What we mean by T1 is actually the first term of the number pattern. The first term of the number pattern is written in short as T1. So when we say T1, we mean the first term. In this particular example, T1 should be equal to 5 because 5 is the first term. T2 means the second term. So second term is written as T2 in short. So we can write T2 is equal to 7. Similarly, T3 is the third term of that number pattern. And so T3 in this particular example is equal to 9. Right. You can continue counting. For instance, you can go to T4, you can go to T5, T6, and so on. Later on, we will look at what we call Tn. Tn is therefore the nth term. So the nth term is written as Tn. Now, in this case, n could be equal to 1, or n is equal to 2, or 3, or 4, and so on and so on. So n can be anything, but this is what we call the general term, Tn. We will look at that one later. The second thing I want us to look at is the idea of extending a number pattern. Given the first 3 terms of a number pattern, it is possible for you to tell exactly what is happening and how those terms are formed. And so you can extend the number pattern. Like in this particular example, we're starting off with a 5, then 7, then 9, then 11. Clearly, you will notice that it's like we are adding a 2 every time. So we keep on adding a 2 to get the next number there. So we're adding a 2 to get the next number. And so if they want you to write down the next 3 terms, all you need to do is continue from the last term that is given there. It's 11 that is given. And it looks like in this case, we are always adding a 2. So the next term after 11 should be 11 plus 2, which is equal to 13. The next term after 13 is 13 plus 2, which is equal to 15. The next one after 15 is 15 plus 2, which is equal to 17. They want the first 3 terms, so we can stop there. This is called extending a number pattern by a few more terms. And then we have something called the constant difference. The constant difference, remember, difference means we have to be subtracting. Let's look at number 1 and explain the constant difference using that one. So this is 5, 7, 9, and 11. And you will notice that to get a 7 from a 5, it looks like we need to add a 2. From 7 to 9, we must add a 2. From 9 to 11, we add a 2. So we are adding 2 every time. So 2 is called the constant difference. And the constant difference is abbreviated or shortened rather by the letter D. So D means difference. In this case, the difference is equal to 2. That is our constant difference for the first one. But how do you get the 2? You will notice if you take the second term and you subtract the first term, that will give you 7 minus 5, which is equal to 2. Again, if you take the third term and you subtract the previous term, that gives you 9 minus 7 is equal to 2. That's the same thing if you take the fourth term and you subtract the previous term, which is the third term. That will give you 11 minus 9, which is equal to 2 as well. So to work out the constant difference, you need to take a term and subtract the previous one. So let's use that to answer number 2. We are looking for the constant difference, which is D. So D will be equal to a term minus the previous one. In this case, we can take a 0 and subtract the previous one, which is a 2. 0 minus 2 will give us negative 2. If you don't want to use 0 and 2, you can actually use negative 2, which is the third term. All right. You can use the negative 2. If you subtract the previous term, which is 0, you will still get a minus 2. To describe this number pattern in words, start with a 5, then add 2 to 5 to get 7, add 2 to 7 to get 9, continue adding 2. That will be a complete answer. I know that many of you will just want to focus on the last line. I know under examination pressure, we might accept that, but just teach yourself this is how we describe a number pattern fully in words. And then we need to work out what we call the general term of the number pattern. The best thing to do is, let's use the position of these terms. So the position of the terms, there is a term in position 1, there is a term in position 2, there is a term in position 3, there is a term in position 4, and so on and so on and so on. And then there is a term in position n. And then the term itself is what we shall call Tn. So in position n, there is a term called Tn, which means the nth term. We know that from this number sequence, in position 1, we have a 5. It's given there. In position 2, we have a 7. In position 3, we have a 9. And in position 4, we have 11. So our question is, what is in position n? In other words, what is Tn equal to? If you take the position and you multiply the position by the difference, what we called the constant difference, what do you get? In the first part, if you take 1 and you multiply it by the constant difference, remember we said the constant difference in this case was equal to 2. So the constant difference is 2 for this one. So if you take 1 and you multiply it by 2, you are not going to get the answer 5. We will get a 2. But if we add a 3, then we shall get a 5. So in order to get 5, take the position 1 and multiply it by the constant difference, which is 2, and then add a 3. Now let's check whether that is consistent with all the other terms. So let's look at 7, for instance. For 7, take the position, which is 2, multiply that by the difference, which is also 2. Clearly the answer is 4. But for you to get a 7, you need to add a 3. It looks like this is the pattern. Let's just check one more time with the 9. To get 9, the position for 9 is 3. Multiply the position by the constant difference, we get a 6. And so to get 9, do you see that we need to add a 3? So it looks like this is the rule, this is the pattern, or this is the order of doing things here. But we are looking at this time for Tn. So how are we going to get Tn? To get Tn, we are going to take the position, which is n, and multiply it by the difference, which is 2, and add a 3, because remember we are adding a 3 for these ones here. So we need to do the same thing. If you simplify this, this will give you 2n plus 3. So the general formula is given by Tn equals 2n plus 3. Right. So remember, we said here the general formula is 2n plus 3. How do we use the general formula to calculate more terms? Like, how do we find the 100th term? Remember, the 100th term is what we mean by T100. But we know that Tn is equal to 2n plus 3. So to get T100, because we are using the general formula, we are using Tn to work out more other terms. So instead of n, we now have 100. Do you see that? We now have 100 instead of n. All right? And that means in that expression, wherever there is n, we can put 100. And if you simplify that answer, you will get 203. So the 100th term is equal to 203. If you want the 50th term, then you need to replace n with 50. If you want the 40th term, you replace n with 40. Now let's look at how we continue to use the general term, which is Tn. This time we want to work out the position of a term, which is actually n. Now we are given that Tn, this is the same sequence, is equal to 2n plus 3. And then you get a question like this. Which term of this sequence is 55? In other words, which term in the sequence has a value of 55? You see, the question is it the first term? Is it the second term? Is it the third term? Is it the fourth term? Which term is it? So in other words, we are looking for n here. We are working out n. That is why we need to understand that in this question, we are told that Tn is equal to 55. So which term of the sequence is 55? So we need to work out n. So we substitute 55 where there is Tn. So going back to that, I'll put 55 instead of Tn now is equal to 2n plus 3. And now I've got an equation that I can solve and find n. If I move the 3 to the other side, I'll remain with 2n there. And that means 52 is equal to 2n. Then divide both sides by 2. And we get n is equal to 26. So n is equal to 26. Therefore, 55 is the 26th term. And you can just write 55 is T26.